This is a project entitled Liquefaction Hazard Assessment for Resilient Schools in Greater Metro Manila, a liquefaction probabilistic model using non-invasive geophysical techniques and limited probe hole. This project was implemented by DOST PHIBOX in partnership with Department of Education. It was funded by DOST PCIEERD, and the rationale behind is to simulate the 7.2 magnitude earthquake and assess the impact of selected DepEd public schools in Greater Metro Manila, and eventually establish a cost-effective, non-invasive geophysical method with limited probe hole to assess liquefaction. It has the project duration of 3 years that ended in June 2022. Liquefaction is a phenomenon where soil strength and stiffness are reduced by earthquake shaking or rapid loading. If you have a building on top of a loosely packed grains of soil and hard together by friction, pore space are filled with water. Then when you have an intense ground shaking due to earthquake, it destabilizes the soil by increasing the space between grains. With its reduced loss, the soil flows like a liquid, wherein the building tends to tilt, sinks, or the stability declines. Here are some historical impacts of recent earthquakes, like the June 16, 1990 earthquake and the April 22, 2019 Central Luzon earthquake, wherein you see several buildings are tilted and buoyant structures floats as a result of liquefaction. The objective of this project is to establish a new methods in liquefaction potential assessment using geophysical and limited probe hole, correlate subsurface geology with geophysical data, eventually use it as a model, and determine the liquefaction potential of 60 selected DepEd schools in GMMA. Likewise, eventually, we recommend mitigation measures against impact of liquefaction, establish correlation between non-invasive method to traditional standard penetration test, producing cost-effective solutions, and to establish in situ seismic response methodology and analysis of school buildings. Here are some equipment that we used in the project. So we have the screw drive sounding. It's a relatively portable screw drive test. And we have the refraction microtremor and the three-component microtremor and the ground penetrating radar. So here are some sample data acquired. So we have the screw drive sounding where you have the N value and the fine contents, the refraction microtremor, the shear wave velocity, the three-component, and the ground penetrating radar. Of the different schools in GMMA, wherein we have 63 sites investigated, and the red dot shows areas high to liquefaction, the yellow one are moderate, the green one are low to none. Here is the comparison employing the standard penetration test compared to screw drive sounding, wherein the standard penetration test is labor intensive, quite expensive, and invasive, comparing to the SDS, and we get a result of 0.75 correlation. Comparing N value of the SPT as compared to seismic wave velocity using a measured PS lagging and refraction microtremor, we also get a good correlation. Likewise, we analyze building response using low-cost seismograph wherein we use Raspberry Shake and employ them in different floors of the building and establish the site response using ETAB. Here are some potential impact comparing geophysical techniques to the traditional survey. So the traditional survey is standard penetration test. Each site costs around $1,500 and it takes 2 to 3 days to, to do the test. Wherein if you use screw drive testing, it's around $150 and you get around 1 to 2 hours of test duration per site. Likewise, for refraction microtremor, around $500 and also 1 to 2 hour per site. So it's quite efficient method using this new method. So here's the project journey and call for adaptation to geotechnical engineers. Since these new techniques, a robust datasets were generated and tested on 60 sites with extensive geophysical data and borehole tests. The project implementation was implemented largely during the pandemic. This caused some delays in the field data acquisition, but later on, during lowered restriction, helped in rapid data acquisition since there are no students in the campuses. The new method introduced are rapid, non-invasive, less manpower to operate, make it efficient alternative through traditional method. Since these new method were established, they are ready for adaptation among geotechnical practitioners catering potential liquefaction assessment and building response and health monitoring. Thank you very much.